So in this video, we're going to go over the problems that are in the Unit 2 test review. So in this first question, it says to identify the graph of f of x equals the absolute value of x minus 1 plus 5. So whenever I'm doing graphing questions, I always like to refer to Desmos because it gives you a nice visual of what the graph is supposed to look like. So we have the absolute value. So in this video, we're going to go over the solutions to the problems that are in the Unit 2 test review. So this very first question is a graphing question. It's asking us to identify the graph of f of x equals the absolute value of x minus 1 plus 5. So whenever I'm doing graphing questions, I always like to use Desmos because it gives us a nice visual of what our graph is supposed to look like. So we have the absolute value of x minus 1, and then remember the plus 5 needs to go outside the absolute value. So you can see that this graph will open up. So all our answer choices do match that. But notice that the vertex is right here, and that vertex is going to be at 1, 5. So notice that answer choice B is the only one that has a vertex at 1, 5. You can see, so notice that answer choice B. So in this video, we're going to go over the solutions to the problems that are in the Unit 2 test review. So this first question is a graphing question, and whenever we're doing graphing, I always like to use Desmos. So we're going to go ahead and type in this equation, f of x equals the absolute value of x minus 1, and then remember the plus 5 needs to go on the outside. So notice that this graph does open up, as do all our answer choices. Another thing you can notice it does is that it has a vertex at 1, 5. So notice that the only graph that has a vertex at 1, 5 is going to be answer choice B. Notice another key feature here. We have this graph crossing the y-axis at 0, 6, and that's another feature that's on this graph. So the key features and matching to the graph in Desmos can help you answer these questions. Let's try number 2. So number 2, it says identify the graph of negative 3 absolute value of x minus x plus 5. So we have f of x equals negative 3 absolute value of x and then plus 5. Okay, so the first thing we notice here is that this graph opens down, and that makes sense because we have that negative in front. So I'm going to go ahead and eliminate any answer choice that has the graph opening up because we automatically know that's not going to work. So you can see here, based on the shape of the graph, A is looking like a pretty good answer choice. You can also verify by looking at the x-intercepts. See, the x-intercepts are negative 1.667 and 1.667, and that does in fact match this graph A right here, right? Because in B, the graph does not cross the x-axis at those points. Now let's try this problem. It says a machine fills jars of soap. The weight of the jar and soap should have a combined weight of 24 ounces. If the total weight is more than 0.5 ounces different from the desired weight, the jar of soap is unacceptable and removed from the product line. Write an equation that can be used to find the lightest and heaviest acceptable weights of the jar of soap. So remember, this is like a situation that can be modeled by an absolute value equation because we have that central value or the average value, right? So that central value in this case is going to be 24. And then we have the range of values that's allowed, right? So the range is going to be zero point 0.5. So that's going to, be on the other side of our equation. So when we write this, we can write this as x minus 24, and that all goes in the absolute value, and that needs to equal 0 0.5. So this is the equation that's going to allow us to find the lightest and heaviest acceptable weights of the jar of soap. All right, so now we have another absolute value equation and it asks us to solve for x. So we have the absolute value of 3x minus 9 equals 15. So whenever you have an absolute value equation, when you drop the absolute value and rewrite it, okay, this is super duper important. When you drop the absolute value and rewrite it, remember that you have two possibilities, okay? This is going to be 3x minus 9 equals plus or minus 15. I'm still seeing a lot of people just writing 3x minus 9 equals 15 and then solving, but what you're doing here is you're only finding half of the solution when you do that. So you need to actually break it apart. So you have 3x minus 9 equals 15 and 3x minus 9 equals negative 15. So now we just solve the equation, right? So now we need to work on isolating x. So we just go ahead and add 9 to both sides, which gives us 3x equals 24. And then we divide both sides by 3, which gives us x equals 8, right? That's one possible solution. And then over here, we're going to add 9 to both sides. And when we add 9 to both sides, we get 3x equals negative 15 plus 9, which is negative 6. And then we divide both sides by 3, which gives us x equals negative 2. Remember, whenever you're doing absolute value equations, you need to double check and make sure that you don't have any extraneous solutions. An extraneous solution will occur when you take a solution and plug it into your equation and you get something that doesn't make sense. So for example, if I'm trying x equals 8, okay, so if I check that, I have 3 times 8 minus 9, then the absolute value of that should equal 15. So that's telling me the absolute value of 24 minus 9 should equal 15, which is in fact true, right? Because this says the absolute value of 15 equals 15, so that works. Let's try now negative 2. So if we plug that in, we have 3 times negative 2 minus 9, all in the absolute value, and we're checking if that equals 15. So we have the absolute value of negative 6 minus 9 equals 15, which tells us that the absolute value of negative 15 is equal to 15, which is also true. So both of these solutions will work, right? So we have x equals 8 and x equals negative 2. Now let's try this problem. So here we want to solve for x, but remember, whenever we're working with an absolute value, we want to make sure and we first get the absolute value by itself, okay? The absolute value needs to be by itself on one side of the equation before we go ahead and separate into two equations. Well, here you can see the absolute value is not by itself because it has a 1/2 in front. So how do we get rid of that 1/2? Well, some of you may say, well, let's divide by 1/2, right? But remember, we don't usually divide by fractions. What we do is we use this little shortcut and we multiply by the reciprocal, right? Remember what the reciprocal is? We take a fraction and we flip it. So in this case, we're going to turn this upside down. This is going to become 2 over 1. And then I'm going to multiply both sides of this equation by 2 over 1. And that's going to be how I get rid of that fraction. Okay, so I have 2 over 1 times 1 over 2. And then remember, anything I do on one side, I need to do on the other. So I have 2 over 1 times 20 over here. Well, this is all just going to cancel, leaving me with just the absolute value, which was my goal. And that equals, well, 2 times 20 is 40, and 40 over 1 is just 40. So now I can drop the absolute value, right? So I can turn this into x minus 5 and say that it's equal to plus or minus 40. That gives me my two separate cases. I have x minus 5 equals 40 and x minus 5 equals negative 40. Now here I can solve by adding 5 to both sides. And when I add 5 to both sides, I get x equals 45. Over here, I'm going to add 5 to both sides. And when I do that, I get x equals negative 35. Okay, so now let's just double check and make sure. Let's go ahead and plug back in and make sure we don't have any extraneous solutions. We have the absolute value of 45 minus 5, and that does equal 20. You can go ahead and check that on your own. And then if we plug in the absolute value, we have negative 35 minus 5, and that is also going to equal 20. So both of these are actually valid solutions to this equation. All right, now let's try this one. So we have the absolute value of 3x plus 6 equals 5x. So remember, when I drop the absolute value and rewrite this, this is going to be 3x plus 6 equals plus or minus 5x. Okay, so I'm going to break this apart now into two cases. So I have 3x plus 6 equals 5x, and 3x plus 6 equals negative 5x. So remember, when we're solving this kind of equation, remember we go back to that don't call me after midnight stuff that we talked about. I'm going to go ahead and move all my variables to one side of the equation. So here I have this 3x, right? It's basically a positive 3x. So I want to move it over here so that all of the x's can be together. Remember, anytime I move across an equal sign, I need to do the opposite. So the opposite of positive 3x is to subtract 3x from both sides. So when I subtract 3x from both sides, I get 6 equals 5x minus 3x, which is 2x. Now I can solve for x by dividing both sides by 2, which gives me 3 equals x. Now over here, I'm going to do something similar, right? So this is a 3x, so I'm going to go ahead and subtract 3x from both sides. And when I do that, I get 6 equals negative 8x, okay? So now I have to divide everything by negative 8, which gives me 6 over negative 8, but remember I can reduce that. That's going to be 3 over negative 4. So 3 over negative 4 is going to equal x. So now what I need to do is I need to plug back in and make sure I don't have an extraneous solution. So if I plug in 3, I get the absolute value of 3 times 3 plus 6 equals 5 times 3. So the absolute value, 3 times 3 is 9, 9 plus 6 is 15. So that's saying the absolute value of 15 equals 5 times 3, which is 15. And that is in fact true. Now let's go over here. So here we have the absolute value of 3 times 3 over negative 4 plus 6 equals 5 times negative 3 over 4. So that's going to be the absolute value of 9 over negative 4 plus 6 equals negative 15 over 4. And when you simplify this, like you have 9 over negative 4 and then plus 6. So 6 is basically 24 over 4. So 24 over 4 minus 9 over 4 is going to equal 15 over 4. So we have the absolute value of 15 over 4 equals negative 15 over 4. And that is actually not true. It's not true because remember, an absolute value can never equal a negative number. Okay. So this is going to actually be an extraneous solution. So we're going to leave that out. And the final answer is going to be just x equals 3. So that's why it's always important whenever you're solving an absolute value equation to go back and plug in and make sure that your solution does in fact work when you plug it into the original problem. Okay, so now here we have a transformations question. It says describe the transformations that occur when the function f of x equals the absolute value of x is transformed to g of x equals x plus 11. So remember, we're going to look at the change, right? So what is that plus 11 going to do to my function? Well, remember, we think about changes as being a times x minus h plus k, right? So remember, a is the number that goes in front, and then h is going to be the value that goes inside our absolute value. So remember, if we have something that's like an x plus h situation, it's going to shift left h units, right? It's like the opposite of what we think, right? Because we think left is usually minus, but whenever we have x plus h, it's actually going to shift left h units. So here you can see this plus 11 is actually a value of h, right? If it was a k, it would have been on the outside of the absolute value. So since it's a plus 11 on the inside, we're going to say that it's shifted left 11 units. And I want you to realize on these transformations questions, you can always use Desmos to double check your work. In fact, I strongly encourage you to use Desmos because if I type this in, I have f of x equals the absolute value of x, right? That's my parent function. If I type in g of x equals the absolute value of x plus 11, you see I get a very nice visual of how my graph has changed. And if you're confused on the left or right thing, you can see here, it's very clear that it does move left 11 units, right? You can tell by looking at the location of the vertex. Okay, so now here it says the function f of x equals the absolute value of x undergoes a vertical compression of 1/4, is shifted left 3 and shifted down 5 to become g of x. Write the equation of g of x. Okay, so we have to think about what all these transformations are. So remember, we're thinking g of x equals a absolute value of x minus h plus k. Okay, so vertical compression. So if you use that chart that I gave you, it tells you that A tells us whether we have a vertical compression or not. Okay, so that's how I'm going to kind of fill in these values on this equation. So vertical compression of 1/4 means that 1/4 goes in front, and then I have the absolute value. Okay, shifted left 3. Remember what we said, if it's an x plus h, it's going to go left. So that means I'm going to turn this into an x plus 3 inside my absolute value. And then it says down 5. Okay. So it's a minus k means we go down. So that means that this is going to become a minus 5. Okay. So this is the final equation that I think is going to reflect this transformation. But like I said, I'm not sure. So what I'm going to do is I'm going to go to Desmos and I'm typing in this equation, right? G of x equals 1/4 absolute value of x plus 3 and then minus 5. Okay. So let's look at these two. Let's see. Is it vertically compressed? Yes, it is vertically compressed, right? You can see this graph is a lot wider than the original. Is it shifted left 3? Well, let's look at the vertex. Here it was at 0, 0, and then here it is at negative 3. So it did go left 3. Did it go down 5? Yes, it did, right? Because this y coordinate was at 0, and now this new y coordinate is at negative 5. So that's how you can always use Desmos to verify on the transformations questions. Okay, so now let's try this problem. Let's solve the inequality 4 times the absolute value of x minus 3 plus 5 is less than or equal to 13. All right, so that less than or equal to, remember that's very important. That tells us that we have an and inequality. So when I rewrite this, once I have the absolute value by itself, I'm going to think about, how it's going to turn into an and. But remember, we always need to first isolate the absolute value. So we have 4 times the absolute value of x minus 3 plus 5 is less than or equal to 13. So to get that absolute value by itself, well, I need to get rid of that 4 and I need to get rid of the plus 5. So we always add or subtract before we multiply or divide. So I'm going to go ahead and subtract 5 first. And when I do that, I get 4. 4 times the absolute value of x minus 3 is less than or equal to 8. Right? The absolute value is still not by itself because I need to get rid of that 4. So I'm going to go ahead and divide both sides by 4. So that gives me the absolute value of x minus 3 is less than or equal to 2. Now I can go ahead and turn this into an and inequality, right? I can write this as negative 2 less than or equal to x minus 3 less than or equal to 2. So I can solve this all together. I can just go ahead and add 3 everywhere. And when I add 3 everywhere, that is going to give me negative 2 plus 3 is 1, less than or equal to, here I just have x, and then I have less than or equal to 5. Okay, and so that is the solution to this inequality. It's just one big compound inequality. All right, now let's try solving this inequality. So here you can see we have a greater than sign. So this is going to turn into an or inequality. But remember, before I rewrite that, I need to first isolate this absolute value. So we have 4 times the absolute value of 2x plus 4 is greater than 24. So that absolute value is not by itself because it has a 4 in front. So I'm going to go ahead and divide both sides by 4. So that gives me the absolute value of 2x plus 4 is greater than 6. Okay, so now when I rewrite this as an or inequality, this is telling me that 2x plus 4 is less than negative 6, or plus 4 is greater than 6. So now to solve this, I can go ahead and subtract 4 from both sides, right? Because I'm going to work on getting x by itself. So I have 2x is less than negative 10. And then I divide both sides by 2, which gives me x is less than negative 5. So here I'm going to subtract 4 from both sides. And when I subtract 4 from both sides, I get 2x is greater than 2. I divide both sides by 2 and I get x is greater than 1. Okay, so that's going to be my solution. X is less than negative 5 or x is greater than 1. And those are the two solutions to this inequality. Okay, so that's all the problems in the test review. If you have any questions after going through this, remember to please email me or try to set up a one-to-one.